So hi, everyone. It's getting quite thin in the audience. I guess the partying on this stage yesterday just is showing right now. But nonetheless, we have next up Frederik Ramm. He will talk to us about OpenStreetMap and look with us under the hood. So give it up for him.
Thank you. We're about 10 minutes late, but those of you who have arrived by train will probably know that this is the new normal. Okay, a few words about myself. I've been with OpenStreetMap since 2006. OSM is becoming 20 years old this year, so there'll be a big party sometime in August. Worldwide. We don't know exactly what form it will take yet. So I've been with OSM since 2006, and I work here in Karlsruhe with GeoFabric as a small consulting company doing stuff with OpenStreetMap. I've been on the boards of the OpenStreetMap Foundation and the FOSGIS, that's a local chapter of the OpenStreetMap Foundation, for a while. And nowadays, my main job in OpenStreetMap is that I'm a member of the data working group. And the data working group is a bit of a misnomer because it isn't so much concerned with the data itself, but with vandalism and disputes between OpenStreetMap users. So in my day-to-day OpenStreetMap volunteer work, I see much of the underbelly of a big community project when people don't agree about something and want to harm the project. Anyway, let's talk about OpenStreetMap. A few numbers, a few points about OpenStreetMap for those of you who haven't heard about it yet. OpenStreetMap is a huge database of geodata, so it's basically the Wikipedia for geodata. It's created entirely by volunteers. Occasionally, there are companies who pay people to add some data to OSM, but the bulk of OpenStreetMap data is contributed and edited by volunteers. It's under an open license. More about that later. The servers that power OpenStreetMap are run by the OpenStreetMap Foundation, and they are mostly located in the UK, Ireland, and the Netherlands. The OpenStreetMap Foundation itself is a UK organization. It's a very small organization that has virtually no budget. I think it's 500,000 euros or something. They have one full-time employee and a couple of people who are helping part-time. It's really a very small organization compared to the size of the project. The OpenStreetMap project doesn't really have any kind of formal leadership. It's more of a movement. It's lots of volunteers doing their stuff, and the OpenStreetMap Foundation is not so much concerned with controlling what people do and telling people what to do, but instead just making sure that the servers are working, and that's almost it. OpenStreetMap collects data from the very big, like this polygon for all of the Iberian Peninsula, to the very small, like this individual waste paper basket somewhere here in Karlsruhe. All of this can be recorded in OpenStreetMap, and believe me, lots of people do record these things. A few numbers about OpenStreetMap. The worldwide data set, if you can download the whole OpenStreetMap database, and it's about 75 gigabytes in a protobuf format, which is the format that we normally use for OSM data. It's optimized for that kind of representation. But you can also download it as an XML file, and then it will have about 1.4 terabytes. We have more than 10 million users worldwide. About 60,000 of them are active and actively contributing to OpenStreetMap every month. The others are people who have signed up years ago to put their own house on the map, and then they went away again. The OpenStreetMap database has 9 billion nodes. Those are individual points with coordinates, and 1 billion ways, lines, or polygons. More about that later. and the consulting company Accenture has done a value assessment of OpenStreetMap in 2020, and their result was its worth is about 2 billion euros. What they did is they basically looked at the data that was in OpenStreetMap, and they computed the number of hours that were required to create that amount of data, and then they said, okay, every hour costs so and so much, so that's certainly no one has actually invested 2 billion euros, but that's what consultant companies come up with. The license that OpenStreetMap data is under is the so-called Open Database license. It's a license that has been specifically written with OpenStreetMap in mind. It's an attribution share-alike license, much like the GPL that many of you will be familiar with, or the CC by SA that is used by Wikipedia. It's based in European Union database right, where protection for database exists. It doesn't so much exist in the US, so there are some shenanigans in the license that make sure it's supposed to work in the US as well. The OpenStreetMap Foundation is the licensor, so the OpenStreetMap Foundation publishes the database under this license. And the license differentiates between derived databases, which have to be made available under the ODBL, so it has the share-alike component in that regard, but it also knows the concept of produced works. So when you make something from OpenStreetMap data that is not a database, like an image, then you only have to follow the attribution regulations, but not the share-alike. That's a big difference between the ODBL and the Creative Commons license. Now, the architecture of OpenStreetMap. At the center of OpenStreetMap, we have a database. This database is basically what the OSMF is operating, or this database, and there's an API in front of that. It used to be a Rails, Ruby on Rails API, and now it's partly in C++, partly still Ruby on Rails. This API is accessed mostly by editor software. There's a popular standalone editor, JOSM. There's an editor called ID, which is built into the website. If you go to openstreetmap.org and you click on edit, then you will basically land in this ID editor. And there are also many different mobile editors. For example, one is called Vespucci on Android, or GoMap on iOS, where you can edit OpenStreetMap on the go. And all your edits will go directly via the API into the central Postgres database. From there, OpenStreetMap data is published in so-called planet dumps, which means that once a week, a new file is generated that contains all the OpenStreetMap data, a current version of it. And there are also diffs, so every minute, in addition to the weekly dumps, every minute a small diff file will be published that has all the changes since the last minute. And then there are basically processing and consumers, so there are services that use these planet dumps and these diffs to replicate OSM data in their own database and produce something from it, for example, map tiles, and we will hear about more about that later. This is a slide that will not be in the PDFs that you can download because of copyright reasons, but I had to include it anyway. This is a situation that I often encounter when in my business, in my day-to-day business life. I have customers coming saying, I need an OpenStreetMap server. And I say, well, what exactly do you want? Because obviously, the central OpenStreetMap server that is run by the OSM Foundation is focused on enabling people to edit the map, right? And this is mostly not what people want when they come and say, I need an OpenStreetMap server. Mostly what they want is they want to use the data in some form. And I want to discuss a couple of different things that you can do with OpenStreetMap, a couple of different ways in which you can use OpenStreetMap data for your own purposes. Many of you will be familiar with map servers. You will probably have had use cases where you had to integrate maps into your Neos managed things, and there are a couple of plugins that allow you to do that, that allow you to abstract from the map providers, where you can just say, yeah, I need a map here, and I want to display some dots on top of it, and then you can choose OpenStreetMap as one of the providers, or you can choose different providers. But this is only basically the user side. You have some library that loads these tiles. Someone has to create the tiles and make them available. And that happens through tile servers. Another thing that people often want to do with OpenStreetMap data is routing or directions. You basically have 2 points and you want to find the best route from A to B. There are various different open source routing programs that allow you to do that. Another thing that you will often need when you do something with maps is geocoding, because you simply want to search something. You want to have a map with a search box on top where you can type something in and then the map zooms to the right location. Or you want to geocode addresses, like you have like a customer database with hundreds of addresses, or an event database with event locations, and you want to show them on the map, so you need coordinates and not just addresses. This is what geocoding does. And of course, you can also query the open database, the OpenStreetMap database, in any number of ways to make detailed queries like give me all buildings that are in the vicinity of waterways or stuff like that. So complicated analysis for whatever reason. And finally, mobile apps. Of course, there's a huge market for mobile apps that find the best routes for you from A to B, or show a map of your current location. Those work with OpenStreetMap also, often by downloading the planet file and just splitting it up in different downloads for the customers. I want to go over these things in a little bit more detail. Let's start with the data model from OpenStreetMap. When you edit OpenStreetMap, you have to know a little bit about how this works in the backend. And I said initially we have like so and so many billion nodes. And a node in OpenStreetMap is actually a single point on the map that has coordinates. And if you look at the sort of, this for example is a bollard mapped in OpenStreetMap. So a small obstruction for people that they can't go in here with their cars. Typical node has an ID, has some information about what it is, has last modified date, and we also record who edited it last, and of course the coordinates. These are the so-called tags, and I have another slide about that later. Oh, I have another slide right away. Tags are formed from keys and values. So, for example, a road in OpenStreetMap would have a highway tag that says, okay, this is a residential road. Maybe a surface tag, or maybe if it's a building, it would have information about the roof shape, or if it's an amenity, it would have information about what kind of shop it is, or it would have a name, streets again have a name, or reference numbers, width, heights, whatever. So there are like 30,000 different keys in OpenStreetMap. Not all of them make sense, because you can just create new keys. You don't have to ask for anyone to vet them or allow them. People can map what they want. Ways are linear geometries in OpenStreetMap. So like for example, this road here, it will consist of a number of nodes that will be referenced by IDs, and it will also have a couple of tags and stuff. And then we have more complex things called relations. Relations are used if you want to combine lots of ways into, say, a route for a bicycle trip or for a bus route or something like that. And we also use relations to model more complex things like turn restrictions. For example, are you allowed to make a right turn or left turn at a certain intersection? We also use them for complex polygons. A simple polygon would simply be a way that is closed, but a polygon that has a hole, or a real multi-polygon that consists of several bits would be modeled as a relation. But that's just, I just wanted to give you a quick overview about this. You don't normally have to know, because the editors will abstract this data model from you. And you basically, if you work with one of the editors, you will just say, okay, I would like to record a restaurant here. And then the editor already has presets and leads you through the process and says, please fill out these fields, and then something will be uploaded. And when you want to use OpenStreetMap data, you don't have to bother with the data model either. You can load it into a Postgres database with a free software called OSM2PGSQL, and that gives you a nicely sorted tables in Postgres that you can then query and work with with standard SQL commands. You can also get shapefiles, which is a common format in the GIS world. If you run a GIS software like QGIS or Esri's ArcGIS or something, it can directly load shapefiles, and you can download shapefiles for different regions from download.geofabric.de. They are prepared freshly every day from current OpenStreetMap data. And of course, you can just grab some piece of software that uses OpenStreetMap data and run that. And now comes the point where I will go into details about the different pieces of software and the different processing things that you can do with OpenStreetMap. And the first is map tiles. As I said, many of you will be familiar with map tiles because you can't load the whole planet into your browser at once. You have to split it up in little squares, little rectangles, and then the browser will load the individual bits that it needs to display the map. For those of you with a cartography background, the Earth is a sphere, so anything you record in latitude and longitude is basically something that you would have to draw on a sphere to make it work. And if you don't have a sphere but a flat screen, you have to use something that's called a map projection that tells you how can I just translate these things into pixel coordinates. And most map tiles use a projection that has been invented by Google, and it's called EPSG 3857. All map projections have these codes. It is possible to create map tiles in different projections, but not common. Map tiles also have fixed zoom levels, starting at 0. On zoom level 0, the whole planet is in one tile, and then it goes up from there. So basically, a zoom level is a bit like a map scale. When you say, I have a 1 to 10,000 map, that roughly corresponds to a certain zoom level. Map tiles, as I said, allow the client to load only the bits of the map that it wants. And there are two major technologies in map tiles, raster tiles and vector tiles. You might have heard of these, or you might have just used them without knowing what you were using. And I will go into a little bit of detail about this in a minute. Here's an overview that shows the different zoom levels. So on zoom level 0, one map tile contains the whole world. And then as you progress down this pyramid, every time you increase the zoom level, you double the number of tiles on each axis. So the total number of tiles is 4 to the power of zoom level. So 4 tiles to cover the whole world on zoom level 1, 16 tiles to cover the whole world on zoom level 2, 1 million tiles roughly to cover the world on zoom level 10, and so on. I sometimes have people coming to me at my day-to-day job saying, I want, can you produce the whole world, tiles for the whole world for me, zoom levels 0 to 18. And I say, well, yes, but you will need something like 60 terabytes of disk for that, and it'll take 2 months to produce the tiles because it's a huge load of tiles. Raster tiles. Raster tiles are rendered on the server. So the client says, I want to download this map tile, and then the server is responsible for making a small PNG image that contains this part of the map. And in your client, you will often use a library called OpenLayers or Leaflet to display those tiles. The tiles are typically PNG images with 256 by 256 pixels. They don't have to be. You can also have like JPEG or WebM or something. And you can also have larger resolution PNG tiles, but this is the standard. And raster tiles will be produced on zoom levels 0 to 18 or even more. If you go to OpenStreetMap.org, that will serve tiles up to zoom level 19. Zoom level 19 is already pretty high, so on zoom level 19, basically, one tile is one building. But you could, in theory, have even higher zoom levels. If you want, as I said before, if you want a raster tile server to have worldwide coverage, then it needs to be built in a way that it produces the tiles on demand, because you cannot create zoom levels 0 to 18 for the whole planet. It's just too much, takes too long. It's not feasible. So what you will typically do is you will set up a tile server that is able to create these tiles on demand, and then you can pre-render some of the, say, zoom levels 0 to 12 so that you have faster responses. And then if someone zooms in to a location that hasn't been looked at by anyone before, the server will then produce that tile on demand and deliver it to the client from the Postgres database that it has with all the OpenStreetMap data in it. That's how raster tile servers work. It is possible to pre-compute tiles for a whole region and have them available as static content on a server. But that only works for small regions. Like if I am the city of Cologne and I want to have a map covering the area of my city, I can do that. I can pre-compute the tiles on zoom levels 0 to 18 on my and put them as static content, static PNG files on my server. But if I want to do the same for all of Germany, it's already difficult, and for the whole world, it just doesn't work. Here's an overview about how the raster tile world works. You have a client. The client is a website with a map in it. And the map requests raster tiles from a raster tile server. And the raster tile server is basically will have a disk cache, and it will try to serve those requests from its disk cache. And if the tiles are not there already, it will request them from the raster tile generator and say, please quickly build me a raster tile for this zoom level at this location. And the raster tile generator will then do that based on its Postgres database, which has been loaded with OSM data, and based on the map style that has been programmed, because obviously you can have different maps that look differently. And this will all be done on the server, and the client just downloads the ready-made PNG files. This is the typical toolchain for raster tile, and this will usually be one server. So there's excellent instructions on how to set this up on a website called switch2osm.org, and tells you everything you need to know to set up a raster tile server like this yourself. Obviously, you can also buy this as a service from companies like ours, but it's totally possible to just set this up yourself with entirely open source software. Vector tiles. Vector tiles is the hot new shit. Everyone wants vector tiles because they are cool somehow. It's not everyone is exactly clear about how and why they are cool, but it's the new thing that you want to have. The main difference between vector tiles and raster tiles is that vector tiles are rendered on the client. So the client, meaning either the website or your mobile phone, actually translates the geodata into a map, which means that with vector tiles you can do stuff like you don't necessarily have to have north up. You can basically rotate the map, or you can maybe switch the color scheme to a dark color scheme or something on your device without having to involve the server. Whereas with raster tiles, the server would have to serve different tiles. Typically, you do not use open layers or leaflet, although you could. Most people who do something with vector tiles use a client-side library called MapLibre GL. And vector tiles take the format of MVT. Mapbox vector tiles is basically that's what this stands for. Although the term MVT tile doesn't, the term MVT also only says something about the transport format. It's basically like when someone says to you, I will send you an Excel sheet with this information. They say something about the transport format, but they don't say which columns will the Excel sheet have and which rows and how will data be organized in that Excel sheet. That it doesn't say that. So you need the extra information about what data schema will you be using inside your vector tile, and there are various schemas currently available. They basically define which layers of information will there be, how much information about certain OSM objects will be in the file, and so on. Vector tiles are typically only produced for zoom levels 0 to 14 and not higher than that. If you zoom in higher, the client will simply take the data that is in the zoom level 14 tile and overzoom. Because it's vector tiles, the resolution will not suffer. If you were to do this with raster tiles and then you overzoom something that is made for zoom level 14, it'll just all get pixely and not look very well. Whereas with vector tiles, you can do that easily. Vector tiles can easily be pre-generated worldwide. So because they are only zoom levels 0 to 14, so that is something that you can run. You can run a command that produces all these tiles. And it takes, on a fast machine, it takes 2 or 3 hours to produce all of the vector tiles for the whole planet. And the resulting data volume is about 100 gigs, so it'll still fit on a USB stick or something. When you produce vector tiles, it's basically the same image that I had before. You have a client here, for example, the MapLibre library, and you also have a map style, but the map style in this scenario is not consumed by the vector tile generator. Instead, the map style is consumed by the client. So the vector tile generator uses OSM data and the data schema to produce vector tiles, make them available on a server to download for the client, and the client will then download these vector tiles and then use the map style to decide how to render the map. It is important to know whether raster tiles or vector tiles, you can make your own map. There are, of course, various companies and open source projects that offer some kind of ready-made map tiles that you can download with OpenStreetMap, made from OpenStreetMap data. But you can make your own stuff. You can make a map specifically for cycling, or that specifically shows infrastructure data or public transport data, whatever you want. You can make a map that shows all the labels in a different language, because OpenStreetMap usually records place names, at least for the larger places, in a variety of languages. And there are people who have basically made a Welsh map for all of the UK, where all the place names are in Welsh, or whatever. You can have different map styling. For example, if you make a website for a customer who is very much into corporate identity and wants their own color scheme reflected in the map, you can do that with raster tiles or vector tiles, both possible by modifying the map style. So you're not dependent on the map styles that are out there. You can make your own stuff with OpenStreetMap. More geocoding. As I said before, geocoding, forward geocoding means finding a location for an address or a search term. Reverse geocoding means find the address for a given location. Sometimes you need one, sometimes you need the other. In OpenStreetMap, there are the most common software that most people use is called Nominatim, or you can also use other products called Photon or Pelias. all three of them are open source software, so you can download this, you can run it yourself if you are concerned about data protection. Because other than tiles, with tiles, if you have a tile server, the only information that flows to the tile server is basically which tile do you want, right? This IP number has requested this tile at a certain time. There are people for whom privacy is so important that they don't even want that. For example, a customer of mine is a police institution, and they don't want anyone to know which map they're looking at. But mostly it's not so privacy relevant. With geocoding, it's slightly different because people search for full addresses, or they might even put in more information like a certain name of a doctor or something, and you can derive more information about the person who searches something from log files. So if you want to run your own nominatim server for privacy reasons, go for it. It's no problem. It's all open source. There are a couple of weaknesses in OpenStreetMap at the moment recording geocoding, and that is mostly postal codes and house numbers. In Germany, both are relatively good. We have all postcodes, and we have, I'd say, 60% of house numbers. But there are countries in which we only have 5 or 10% of house numbers. We generally have all the streets, but knowing where exactly a certain house number is doesn't work in all countries with OpenStreetMap, simply because the data isn't there yet. And also, postcodes are difficult. People who are, or developers from Germany, often assume that postcodes work the same all over the world, like they work in Germany. Or I simply I enter a postcode and I know approximately where that person, where that location is. But it doesn't work that way in many other countries. The English have postcodes that are much, much smaller. They just encompass a couple of dozen households. Or the new postcode system in Ireland is completely, it doesn't have contiguous regions for postcodes. It's basically you have one postcode here and another postcode. The house next to it has a completely different postcode. So it's not easy. So much for geocoding. Routing and directions. Routing software finds the shortest, fastest, best route for a given vehicle type or for pedestrians. This all depends on the profiles that you enable in the routing software. It can also do stuff that's called track matching, where if you have a GPX track from a trip that you have taken, and now you want to know what are the names of the streets that I've been walking along, basically you want to find out, okay, which elements in the OSM data are the best match for this GPX track. This is something that routing engines can do for you. They can also compute isochrones, meaning you can enter a location and a time. You can say, okay, from this location, which area is reachable in 10 minutes or 20 minutes or something. This is something that people often do when they need to plan for, where am I going to open the next branch of my bakery or something? I want to see who is in a 5-minute radius, who is in a 10-minute radius. And you can do stuff like route optimization. Route optimization is stuff like traveling salesman problem, where you say, okay, I want to visit these 100 locations. What order should I visit them in order to be to do it in an optimal way? The weaknesses of OpenStreetMap in the routing and directions department are mappers, volunteers in OpenStreetMap. They tend to record the stuff that is important for them, stuff that they see, and stuff that immediately is reflected on the map. So if they see a road that is still missing, they say, yeah, I found a road that wasn't on OpenStreetMap yet. Let me just put it in. And it'll show up on the map immediately after. However, when there's a bridge and the bridge has a height restriction, it says, max 2 meters 50 or something, this is not something that will even show up on the map normally. So people are slightly less enthusiastic about mapping that kind of detail. So it's sometimes missing from OpenStreetMap. Also, turn restrictions aren't so popular. So compared to commercial data, OpenStreetMap has some weaknesses in that department. Which software would you use for routing and directions? There's also a variety of open source products available. Most popular are OpenStreetMap, OSRM, open source routing machine, actually developed by a guy here at the Karlsruhe University, Grasshopper and Valhalla. OSRM and Valhalla are C++ products. Grasshopper is Java. They all have their particular strengths and weaknesses, but they all do the job. There are also 2 open source programs called Vroom and JSprit. Those are your go-to tools for doing route optimization of any kind, like the traveling salesman problem, or various very complicated forms of that, where you would, you have a vehicle that needs to collect garbage from certain locations, but it can also only collect so and so much garbage before it has to return and drop it off, and so on and so on. So that's what these programs will do for you. All based on OpenStreetMap data, all working very well, being used by big courier companies like DHL and stuff. So properly tested. Other than tiles and also geocoding, it is very difficult to do incremental updating with routing engines. So when you have something like a worldwide routing graph in OSRM or Grasshopper, and now you want to load the new data from OpenStreetMap, you will usually have to create the whole thing again, instead of just applying a little change to it. That's a bit resource hungry, especially the fast algorithms. OSRM and Grasshopper support something called contraction hierarchies, which is a very modern routing algorithm for quickly finding routes between 2 points, and those consume a lot of memory. Building a worldwide OpenStreetMap routing graph with OSRM takes 400 gigabytes of RAM. It doesn't take that much to run it later on, but you need that much to prepare the routing graph. And there's often a problem for people using all those modern cloud-based thingies where, let's just fire up a node that does this with our Kubernetes thingy, whatever, something. It's all magically in the cloud and all works. And then you say, yeah, but can you fire up a node that has 400 gigabytes of RAM? Oh, shit. Yeah, we don't know. So, depends. Database queries. Sometimes all of these standard things are not enough. Sometimes you want to query OSM data in a very, very specific way. As I said before, you want to find buildings that are next to waterways, or you want to identify areas which have lots of private swimming pools. Whatever. There's lots of stuff that you can do once you have OpenStreetMap data in a database. And if you have any kind of use case like that, I would always recommend to import OpenStreetMap data into a PostGIS database. That gives you the best performance. However, there's also something called the Overpass API, which is a public API that you can use, and it has a custom query language where you can do stuff, where you can do some general purpose OSM querying. And it also has a WYSIWYG tool called Overpass Turbo, where you can enter stuff and see the results directly in the window. For example, give me all shops within a certain distance of a location. That's what you would do when you have custom database queries with OpenStreetMap. Having said all this, if you use OpenStreetMap in any way, please always make sure that you put proper OpenStreetMap attribution. Because OpenStreetMap data is free. You don't have to pay anyone to use it. You can run your own servers with your own hardware, with open source software. But the only thing that the many OpenStreetMap volunteers who contribute to the project ask of you is to attribute them properly. So put something underneath your map that says map data, OpenStreetMap, and usually we also put the shorthand for the license, so that anyone who uses your map or your product or your website knows that you've been building this with OpenStreetMap, and that they can actually download the data and do something with it, or maybe that they contribute to OpenStreetMap. And I saw that some of you did that already, so very happy if people who use OpenStreetMap also contribute to the project and edit the data. Also, if you want to support the OpenStreetMap Foundation, there's the supporting.osmfoundation.org website, where you can become a corporate member of the OpenStreetMap Foundation and pay something or other per year. I think the smallest, they're supporter, bronze, silver, and so on. You can help the OpenStreetMap Foundation support the project. That was my talk, but I have left some room, have left ample room for you to ask questions. And I hope that some of you have already been playing with OpenStreetMap, and they may have some questions that I might be able to discuss with you. So.
Thank you, Frederik. And yes, they have some questions. One of them you already answered in your talk. It was about why are tiles usually rendered as pixel image and not as vector formats like SVG. Or if you have anything to add, you could.
Yes, of course, I can. Lots. Obviously, using raster tiles is the easiest for the client. So if you have, remember that the whole thing started about 20 years ago. If you have a client that is not as powerful, displaying raster tiles is always the cheapest and easiest for the client in terms of CPU resources needed on the client. And also the whole SVG or something, there was a time when people experimented with that, but that was then quickly overtaken by by today's vector tiles, where you don't actually have graphics in the vector tiles anymore, but just the geodata. And the geodata is then rendered in the front end, which then gives you all the additional advantages of being able to switch the map style in the front end, or like rotate the map and stuff like that. But it's basically just when the stuff was invented, you couldn't count on devices being powerful enough to do anything with vector graphics.
So thank you for that. Where do commercial map providers get turn height restrictions data from? Would these also be viable sources for OSM?
No, because they are copyrighted. There are basically three major, if we talk about worldwide data sets, there are three major worldwide data sets other than OpenStreetMap for map data. And that's the Tally Atlas TomTom data set, and then the Nokia Navtec data set that has been bought by a conglomerate of German automobile companies, and the Google data set. Google doesn't sell their data, and the others have created the others do sell their data, but under strict licensing terms, where you actually have to say, okay, what exactly do you want? And then you pay a very high monthly or yearly fee, and you can't just sort of load the data into OpenStreetMap. And these people have actually created the data by having people drive around and film everything. What usually happens is you will have people in Germany driving around in a car recording everything on hard disks being shipped to India, where they are then processed by people in sweatshops, and people actually look at all the signs on the maps and signs on the videos, and then they record the stuff. Nowadays, people are experimenting with doing that automatically with AI image recognition, but that's not safe enough for them yet to actually produce that.
So I have a good follow-up question for that. Most website plugins directly access the OSM tile server. Where does its fair use policy end? Enterprise access, number of calls, etc.
There is actually a website that is called Tile Usage Policy. I don't have a link to that in my talk, but if you Google for OSM Tile Usage Policy, you will find an exact answer to that, although the answer isn't that exact in terms of you are allowed to make so and so many tile requests. It has something like moderate use is okay, and then you can decide whatever moderate use is. There's an important thing, especially in light of recent vandalism. There's an important thing to say about using OpenStreetMap tiles directly. OpenStreetMap tiles are mainly aimed at use within the project. So when someone uploads something to OpenStreetMap, the infrastructure tries to put that on the map tiles as quickly as possible. And if someone creates vandalism, and we had an incident recently where someone basically smeared another mapper by putting roads basically across the continent, saying so-and-so is an asshole, and there is no automatic protection against stuff like that in OpenStreetMap, so it will show up on the tiles. It will then be quickly noticed and repaired, and it will go away again. But if you have your own tile server or a tile server from someone else who doesn't immediately put all changes up on OSM, but maybe with a short delay, then you are safer against a vandalism like that. So depending on your use case, there are various reasons why it is good to have your own tile server or to pay someone to load the tiles from. First, you get an email address or a telephone number where you can complain when it doesn't work. And with a free service, you can't really complain. Well, you can, but it's a bit of, it's not nice. Second, you don't put load on the donation-funded infrastructure from OSM. And third, you might have a little more protection against vandalism. Having said that, commercial use of the OpenStreetMap tiles is expressly not forbidden. So especially if you run a small project where it's like a website for a small organization or something that has a couple thousand views in a day, no one really cares.
Thank you. I have a last question for you. What are current trends in the OSM universe? What is next on the roadmap?
That's a standard question. Yeah. So OpenStreetMap has become huge, and there are so many different things going on. On the one hand, you have people doing more and more detailed mapping, like indoor mapping, where you can actually, for example, the railway station in Berlin, big thing with many floors, many different shops, and you can actually now in OSM see all the different floors and all the different things and the different elevators and so on and so on. So people are doing more of that together with 3D mapping also. There are some cities in which 3D mapping is so well done that you can actually have 3D views of the city. That's one area. Another area is obviously AI, and we have lots of people experimenting with automatically consuming aerial imagery in order to produce data for OpenStreetMap. Many people in the OSM community are skeptical of that because it tends to produce low-quality data that people then have to clean up afterwards. And cleaning up afterwards is much less fun than just creating the good data right away. So someone who basically dumps a lot of AI-created data into an area might turn away other people who might have been willing to spend more time to do it properly. So the whole AI thing is complicated. And then there's another complicated thing in OSM, and that is mapping in underprivileged regions. It's been going on for a long time. For a long time there has been humanitarian mapping groups in OpenStreetMap. But there's a conceptual problem here, and that is OpenStreetMap started in Europe as a project for hobby mappers. People who had spare time on their hands, people who had the necessary GPS devices and stuff, and they would just map in their spare time. But there are regions on the world where people are so poor that they do not have any spare time because they have to spend all their time trying to get food on the table. They do not have devices that would allow them to map. They might not even have mobile phone coverage. So the question is always how do we get OSM? How can we help these people map OSM? It's a difficult issue that's being discussed a lot. Because it doesn't really help when we say, hey, you know, I'm in Germany and I have some spare time. Let me fire up a map of Sudan and just draw some things from aerial imagery, because maybe I don't have any knowledge of the region and I don't really. Maybe I'm not helping. Maybe I'm just sort of, you know, making things worse. So yeah, those are three things that come to my mind off the top of my head. Another thing that we have lots of issues with recently is right of way, private property. So in general, we map everything in OpenStreetMap, all the paths, everything that we can see, and then someone comes along and says, but this is my private path, and now I have lots of hikers walking behind my house all the time. Can you please delete this from OSM? And then sometimes the request is well-founded, and then we will sometimes delete something, or more likely mark it as private. So it is still in OSM, and people can know that, okay, there is a path here, but I will only use it in emergency because it is private. But sometimes these requests are not well-founded, and they are just sort of, it is actually a public path, but someone would like hikers to take another path. So yeah.
Okay, so thank you for all your insights. And I think we have a speaker present.
Yes, we do.
Oh, a present, a present.
Thank you very much.
Thank you. Okay, so we finished on time.
Thank you very much, Frederik, for your presentation today. And